Hello everyone. So I will talk about 1.1 today in Introduction to Function and Relation. So this session mostly you learn in colleague algebra, Math180 already. So I don't wanna talk about the definition. You may look at the notes in the first page. It's talk about function, range, and domain. Okay, so I'm gonna right away come to the some example and tell you how to do it. So the first one talk about like graph y equal to 8.5 and 8.5x, and a requirement for that for the x is from 0 to 40, and they asked me to state in domain and range. Okay, so let's graph this one first. Firstly, I would like to have a t-table. Okay, and so the first column is for the value of x, and the second column is for value of y, which equal to 8.5x. Okay, so let's choose some value for x. I should not have value less than 0 because I know that the x just go from 0. So 0, and then maybe I choose say 1, and then maybe I choose 10. Okay, and the last one is 40. You know what? I don't want to need number 1 because it looks like the scale is so big. So I just want to choose 0, 10, and 40. Okay. So for x equals 0, what do I have for y? I'm gonna have 8.5 times 0 gonna be 5 times 0 gonna be equal 0. Okay, and then for x equals 10, I have 8.5 times 10, and that's gonna be 85. And then 8.5 times 40 gonna be what? Let me use calculator, but sure. So I have 8.5 times 40. So I have 340. Okay. So this give me order pair as 0, 0, and I have 10, 85, and this one give me 40 and 340. Okay, so let's grab this. Okay. I know that the value of y will go up to 340. So I would like to say here is 100. Here is 200, and here is 300. Okay, and then I have the y is vertical and the x is horizontal. The x is just go from 0 to 40, so I'm gonna say here 0. Here is 20, and here is 40, and I know that is 20, 10 here. Okay, so let me choose another color. So I know that there's a point at 0, 0 origin, okay, and another one is 1085 Okay, 85 is around somewhere here. Okay, and say I have 40 and 340. Okay, I'm going to say 340 is around here. Okay, 340. Make it clear. 340. So this one. Here, okay, and then I'm gonna grab grab a line, go through these 3 points. Okay, perfect. And because the function just go from the function just go from 0 to 40 for x, so I don't want to go below than that and over than that. And I'm gonna say, oh, domain just go from 0 to 40 for x. And for the range, which is a value of y, is actually go from 0, go up to 340. It is a y value, all right? Okay, so that is domain and range for example 1. Let's move to example 2. In here, I give you y equal to 1 over x. It is a rational function, or I mean rational equation. Since you learn in college algebra about how to graph rational equation, you should know that the horizontal asymptote. In this case, it has to be since the degree of freedom. I mean, sorry, degree of the top is less than degree at the bottom. So I'm gonna have horizontal asymptote going to be y equal to 0. Okay, I'm gonna say degree top is less than degree bottom. Okay, and you should know that degree of top in here is 0 because there is no variable, right? And degree the bottom is 1 because the power of x in here, the power of x in here is 1. So you have degree of top less than degree bottom. And now I'm going to talk about the vertical asymptotes. Vertical asymptote will be the bottom equals 0, the value of x. You're going to solve the bottom when bottom equals 0. So bottom equals 0 is x equals 0. Right? Okay. And now you will do the same as t-table. So we're going to say x here, y equal to 1 over x. Okay. So let's choose some value for this. I'm gonna say, okay, let's do -2, -1, 0, 1, and 2, right? Let's see what happens. Okay. You can even do a -0.5 and 0.5, but I don't think that I need it in here. So -2, what do I have? I have 1 over 2 -1, right? -1/2. So for the -1, I'm gonna have -1. I have 0. What happened in here? It's gonna be 1 over 0 is undefined. Okay. So in this case, is make the y is undefined, or I have invalid x. So I don't want to have x in this case. And remember that the rational equation, you will always have the bottom not equal to 0. Okay. So in the case of x equal to 1, I have 1, and 2 going to be 1/2. So now the order pair will give me -2 and -1/2. And then I have -1 and -1. And then I have 1, 1. And this one will be 1/2. Oh, sorry. 2 and 1/2. Okay. So I'm gonna move down to the main range here. Oh, actually, you know what? I'm gonna draw it here. So okay. I know that's horizontal asymptote. Let me using other color. Red color. Horizontal asymptote will be and vertical asymptote will be the y-axis. Okay, and the graph will go along with it. So for the first one, -2 and -1/2. -5, -2. So -2 here, and -1/2. I say here's a -1/2. So I have 1 point here, and then -1 here, and -1 here. Okay. And I have 1, 1, 1 here, and 1 here. And I also have 2 1/2, 2 here, 1/2. Okay, so remember that the graph will go along with the x-axis and the y-axis, so it should look like this. It will never go over than x and y axis. Yeah. So here you can know that's right way. X can be anything except except 0. So I say x is all real number, and x not equal to 0, right? Because x is 0, not requires undefined. And similarly for the range, y can be anything except y not equal to 0. Okay, so that is the main range for this one. And if you want to practice more, you can just go ahead and do example 3. You can pause my video and do it. If you want to see the solution, you can go to my notes that I'm going to post on the report and look at that. Okay, so I'm going to move to example 4 now. Example 4 says sketch the graph of x equal to y squared. And then is this a function? Let's question that. So let's do t-table first. I have x here, and I have x equal to y squared. And I have the y value here. In here, the independent variable is y. So I'm gonna choose some value for y first. Let's say, I don't know, maybe just say -2, -1, 0, 1, and 2. So for x will be square of the y. So let's say, for example, here's -2 square. It's gonna give me 4, right? And then similarly here, I have 1 square is 1. Then 1 square is 1. 0 square is 0. And then 1, and then 4. So this gives me the order pair has 4, -2, and then 1, -1, and then 0, 0, and then 1, 1, and the last one is 4, 2. So according to this, I can I can sketch the graph, and I know that this should be a parabola, horizontal parabola, which go from which have start from 0, 0 origin, and let's say 4 and -2, say 1, 2, 3, 4, and -2. So you have here, and then net and 2. So you have here, you have 1, and then 1 and 1. Okay. You have 0, you have, okay, sorry. I think that's it now. So maybe using other color. Okay, so I connect all these points. Okay, connect all these points. All right. So this is the graph of x equals y squared, and the question is this a function? In order to answer this question, I'm going to say if you have one input, give exactly one output, then it is a function. But look at that. At the input equal to 4, right? You see that input 4 here. But it give me two output is -2 and 2. Okay, so that means what? That means is one input give me two output. We are with -2 and 2, so not a function. Okay, it's not a function. And and if you remember about vertical line test in correct algebra, you can check this graph is just a function by vertical line test. So let's draw a vertical line go through the graph, and let's see what happened. Okay, so this is vertical line test. Vertical line, and let's go through the graph. So I'm gonna check how many intersection point that I have between the graph and the vertical line. I saw that there's two intersection. Okay, so in the vertical line test, it say that if the vertical line cross the graph of a relation in more than one place, then the relation cannot be a function, not a function. Okay, this is not a function. Okay, So yeah, that's it. Let's move to example 5. Okay, so these are the definition here. You can it's just remind you about connect algebra. So I don't want to go with it. You can just read it in my notes. Okay, so example 5. So in here, the graph also for A, also the graph is a parabola, but this is like a vertical parabola. And when I use vertical like this, which like in here I did use like two vertical lines, and I noticed that it just cross only one place. So then I can claim that is a function. Okay. But for part B, I noted that the vertical line cross the graph of the relation in more than one place. So this is not a function easily. Okay. So, and the last topic, I mean the last thing in section 1.1 I'm going to talk about is evaluate the function. So if they ask you the value, I mean if they're giving you the function f of x equal to 4x minus 1, they're asking you what is f of 5. That means what? In here, input is 5, okay? Or I can say input is x equal to 5. So now I'm gonna change everything. I mean all the x to become number 5. Okay? So so I'm gonna have f of 5, okay, equal to okay. So I know that there is I'm gonna copy this down. Copy this function down. Okay. Now the input is x equal to 5. So that means this x here change to become 5. So I change 5. Okay. So it's only 4 times 5 and minus 1. Okay. So 4 times 5 equal to 20 and minus 1 is equal to 19. So that is the answer. Okay. So for me, the now inputs now become z. Okay. Or I can even just say x equals to z right now in this case. And what does that mean? I mean, I'm just gonna change all the variable x become variable z. Okay, change the letter. That's all. So yeah, z to 4 times z minus 1. Okay. So okay, I'm gonna put the red color here. I don't even need the parenthesis because there is no way to there's no way to simplify more. So I just keep 4z minus 1. All right. So problem C. In this case, it's more complicated, but input is what? What do you think? It's going to be x equal to a plus b plus 3, right? So in here, you see that the input is a plus 3, okay? All right. So now, f of a plus 3 will be what? Now, I'm gonna put out 4x minus 1 from here. But what does x now become? X become a plus 3. Okay? I'm gonna change the color so you feel good with that. All right? So can I simplify it? I think I can. I'm just gonna do distribution for that. 4a plus 4 times 3 is 12 minus 1. So f of a plus 3 will be equal to what? 4a plus 11. Okay. So yeah, let's do one bonus problem, and I think most of you maybe will struggle with that. Let's do f of x plus 1. Okay. So in this case, what is input? Input's gonna be x plus 1. It's not x anymore. It's x plus 1. So okay, so I'm gonna write out input is x equal to x plus 1. Okay, and I'm gonna write f of x plus 1 equal to, okay, for x minus 1. Now what is the x gonna change? X become x plus 1. Don't forget the parentheses for this guy because there's a proof. Okay, so now we change become x plus 1 because because the input now become x plus 1. Okay, and I'm gonna simplify it for x plus 4 minus 1. Okay, so I'm gonna have 4x plus 3. Gonna be the answer. Okay, so I'm done with section 1.1, and I hope if you have any question, you can come to my Zoom time and ask me. Okay, time to practice on your XYZ homework. See you later.